Guys, welcome back to this new video in my YouTube channel. So in this video we're going to be looking at the fourth question that came in June 2025 Math Mechanics paper 3. So as you're watching this fourth video, hope you're watching the first, the second and the third part, and it's actually the fourth question. So the question read: two smooth sphere A and B of equal radii and mass is 1 kilogram and 3 kilogram respectively are moving in the same direction on a smooth horizontal floor with speed 4 meter per second and 2 meter per second respectively. Sphere A subsequently collide with B. Given, given the coefficient of restitution between the spheres is 1/3, find A, the speed of A and B after collision. That's 6 marks. B, the magnitude of the impulse exerted by A on B during the collision. That was 4 marks. Then C, the kinetic energy lost during the collision. That was 3 marks. So in total, we had 13 marks for this question. Okay, so guys, I'm going to be explaining as we proceed. So pay keen attention as we start. Okay, so generally we all know that mechanics is based on diagrams. So we have to sketch our diagram to illustrate the issue. We have two spheres, A and B of equal radii and masses 1 kilogram and 3 kilogram. So these are the spheres A and B, this sphere A and this sphere B. They are the same radii. Then the mass of this one is 1 kilogram and the mass of this one is 3 kilogram. Perfect. They are moving in the same direction. They are moving in the same direction on a horizontal floor with speed 4 meter per second and 2 meter per second respectively. Please take note of this word respectively. When we say respectively, it simply means that it's in this order. That means sphere A is moving with the speed of 4 meters per second and sphere B is moving with the speed of 2 meters per second. I mean, it's in this order. Since A came before B, so 4 should be the speed of A and 2 meters per second should be the speed of B. Same thing with their masses. Since A came before B, so 1 kilogram should be the mass of A and 3 kilograms should be the mass of B. Hope this word is well explained and understood. Okay, so they are moving in the same direction with the speed of 4 meters per second and 2 meters per second. So these are the direction that I decided to take. I decided to take the positive x direction, 4 meters per second for the initial velocity of A, then 2 meters per second for the initial velocity of B. Okay, sphere A subsequently collide with B. Given that the coefficient of restitution between the spheres is 1/3, find the speed of A and B after collision. Okay, so this is a diagram before the collision. That is, they are moving in this direction. Yeah, and this one is equal moving. Now, after or during impact, they are colliding. But I just had not draw the diagram during the impact. I drew the diagram after the impact. So after the impact, sphere A will still have the same mass, right? Sphere B will still have another at the same mass still. Now, we don't know if actually they are going to go in, if actually they are going to go in the same direction or not. But now the question is, if they will be going the same direction, that is, if both of them are going to go in the positive x direction, then their velocity should be positive at the end of the day. But if one of them at the end of the day is stationary, let me just say sphere B is stationary, then automatically the velocity should be 0. Please pay keen attention. But if the velocity of A is actually negative, then you mean that after impact, it went behind, not in front. So those are the conditions that we have to note. Because the direction like that we are not setting, but we are going to be sure after looking for the final velocity after collision. Hope it's clear. Okay, so let us get started. So to have the final velocity, we are going to apply two laws here. The first one will be the law of conservation of momentum, and the second one will be the Newton experimental law of the law of restitution. So for the law of conservation of momentum, linear momentum, we know that the sum of initial momentum is equal to the sum of final momentum. And see the law of conservation of energy, that's the total momentum before impact, because the total should be equal to total momentum after impact. Now in our case, we have ma, that's the mass of A. Remember, momentum is simply the mass times velocity. So we have the mass of A, initial velocity of A, plus the mass of B, initial velocity of B, is equal to the mass of A times the final velocity of A, plus the mass of B, the final times the final velocity of B. So if you want to replace everything now, we are going to have the mass of A was found to be 1 kilogram. So one initial velocity of A was found to be 4 kilogram times 4, plus the mass of B, 3. The initial velocity of B was found to be 2, to be equals to the mass of A1, then VA. Remember, VA is the final velocity of sphere A, plus 3 VB. VB is the final velocity of sphere B. Okay, so if you simplify, here we're going to have VA plus VB to be equal VA plus 3 VB equals to 10, because actually this 4 plus 6, that's 10. I can call this equation A. So we're going to go further to apply the second law as a NEL, Newton experimental law, or the law of restitution, which states that the ratio between the velocity of approach and the velocity of separation is equals to E, where E is the coefficient of restitution. So we have VA, the final velocity of A minus final velocity of B, divided by the initial velocity of B minus initial velocity of A, to be equal to E. Now, it will mean that VA minus VB divided by 2 minus 4. Remember, the initial velocity of B was given to be 2 meter per second. That's 2. And the initial velocity of A was given to be 4 meter per second. So pay keen attention. Okay, so we have VA minus VB divided by 2 minus 4 is equal to 1/3. 1/3 is the coefficient of restitution. 1/3. Now remember, the coefficient of restitution lies between 0 and 1. Perfect. So if you simplify this, we're going to have, if you cross multiply, we're going to have 3VA minus 3VB is equals to 2 minus 4 is actually negative 2, is equals to minus 2. You can call it equation B. So now we have equation A and equation B. So if you add them together, we have to eliminate one variable. If you add them together, we realize that we are going to have, if you add the equation A and equation B, we are going to have VA plus 3VA. We are going to have 4VA. Then 3VB plus a negative 3VB is going to be actually 0. Then 10 plus minus 2, we are going to have 8. And from there, you are going to have VA to be equal to 8 divided by 4, that's 2. So it means that the velocity of A is actually, the velocity of sphere A is actually 2 meter per second in the positive x direction. So that means the direction we choose, this direction, was actually good. So this is final direction. So this is actually the direction of sphere A after the collision. So after colliding, the velocity is going to reduce to 2 meters per second and it will be going the same direction. So to have the velocity of B after collision, we are simply going to substitute the velocity of A in any of the equation. So if we try substituting in equation A, we're going to have 2 plus 3 VB is equal to 10. And from there, 3 VB is equal to 8. That's 10 minus 2, 8. And your velocity of B will be equal to 8 on 3. That's approximately equal to 2.667 meter per second in the positive x direction. So realize that actually after the impact, right? After the impact, the velocity of A have reduced to 2, while the velocity of B have increased. And it's just normal because the sphere A gave sphere B another momentum. So that's why the speed has increased because actually the initial speed was 2, but and then we saw that the final speed was 2.66 something. And it's very normal. Very normal. Okay, so hope this part was clear. Now the second part we asked to look for the magnitude of the impulse exerted on A during the collision. Now, to get the impulse exerted on A during the collision, remember impulse is actually change in momentum. But the impulse exerted on A during the collision will simply be the change in momentum of B. Please take note. The impulse exerted on A will be change in momentum of B. Okay, so impulse is equal to change in momentum. Mathematically, J is equal to final momentum minus initial momentum. Yes, like I was saying, the impulse exerted by sphere A on B because the change in momentum of sphere B. So take note of this, please. So the initial momentum of sphere B will be equals to the mass of B and the initial velocity of B. So we're going to have 3 times 2. That will be approximately 6 Newton second. The final momentum of B will be the mass of B times the final velocity of B. So we're going to have 3 times 8 on 3 and we are going to have 8 Newton second. So the impulse will be equals to 8 minus 6. That's 2 Newton seconds. So the impulse on A so the impulse exerted by sphere A will simply be equal to 2 Newton second. Yeah, momentum, or otherwise 2 kilogram meter per second if you want to use Newton second. Now, C, we are asked to look for the kinetic energy lost during the collision. So, to have the kinetic energy loss, the first thing to do is look for the total kinetic energy before collision, then the total kinetic energy after collision. Then after we're going to look for the kinetic energy lost. Okay, kinetic energy is equals to a half mv squared, that's the mass and the velocity squared. So the kinetic energy loss will be equals to total kinetic energy before collision minus total kinetic energy after collision. So since the half is common everywhere, I will factor out my half. I'm going to have the total kinetic energy before collision will be equals to MAU A squared, that's the mass of A, initial velocity of A squared plus the mass of B, initial velocity of B squared, minus MA final velocity of A squared plus MB final velocity of B squared. So if I substitute everything, I'm going to have the mass of A was found to be 4, initial velocity of the mass of A was found to be 1 kilogram, sorry. Initial velocity of A was found to be 4, then the mass of B 3, the initial velocity of B was found to be 2, was given to be 2, Then the mass of A, same thing, 1. Then the final velocity of A was found to be 2 now. Mass of B given to be 3. And the final velocity of B was found to be 8 on 3. So if I complete this by points my calculator, I'm going to have the half into, remember this half is common everywhere. 1 times 6, 1, okay, 4 squared is 16. So that 16 times 1 is 16. Then here 4 squared here, 2 squared here is 4. Then times 3, I'm going to have 12. 2 squared here is 4 times 1, I'm going to have 4. Then 8 squared, 8, 8 squared here is actually 64. Then 3 squared is actually 9. Then the 3 will cancel this 9. I'm going to have 3 back. So so generally I'm going to have 64 and 3. And if I simplify this, I'm going to have 12 plus 16 plus 12 as 28. It has 28 minus, if I add this, I'm going to have 76 on 3. So at the end of the day, if you simplify this, you should have the kinetic energy loss to be equal to 4 on 3, that's 1.333 joules of energy. So that's the energy that was lost during the collision. Yes. So guys, that was just the end. And thank you very much for watching. Hope you learned something in this video. Remember, if you're new in this channel, don't forget to subscribe, and equally just tap that like button so that you can equally motivate us, the team. So thank you for watching, and see you in the next tutorial. Ciao.